thankful to my group member who equally contributed in making this project presentation. The topic that is that we should present today is the ground improvement techniques. Initially, we should go with the introduction that what is ground improvement. The use of mechanical means to improve the weakness of a soil is known as ground improvement. Generally, a geotechnical engineer, they do three or four types of ground improvement technique that are ground improvement, deep foundations, or the remove and replace method. But among all, for shallow foundation, the most convenient and economical procedure is ground improvement. Now, the reason for ground improvement that are it prevents excessive settlement of the surface of the reclamation area when structure like buildings, road, and other foundation are loaded on it. Improve the shear strength of the fill and subsoil. Increase the density of fill mass and subsoil to prevent liquefaction. Improve soil permeability in order to increase the drainage capacity. Initially, the types of settlement which are due to weak soil, that are uniform settlement in which there is no cracks observed. The next one, it is tipping settlement in which from one tip it settles, on the other side it is stable. No cracks visible in this case also. And the third one is differential settlement in which a part of soil that gets settled, it provides cracks in the structure or building. The techniques that we will present today are Vibro Compaction, vacuum consolidation, preloading of soil stabilization by heating or vitrification, ground freezing, vibro replacement, stone columns, mechanically stabilized earth structures, soil kneading, micropiles, grouting. Now the first one, it is called as Vibro Compaction. It uses the vibrulent sustained vibration to rearrange the soil particles of non-cohesive soils into a denser state. It is usually used in granular soil with limited fines content. The action of vibrator, it reduces the intergranular forces between the soil particles and thus allows them to move into a more compact and dense configuration. The required treatment depth, which is pre-designed for each project, it typically range from 15 to 50 feet, but it should not exceed the maximum depth of 120 feet. You can see the picture of a Vibro compactor. It is visible on the right. There are four phases of Vibro compaction where it is completed. Number one is penetration. The vibrulence, it is penetrated into the soil with the help of vibration and its own weight. Number second, it is compaction. In compaction, the vibrulence vibrates in the bottom and it compacted the soil. The third one is backfilling. When the soil is compacted, additional material is added in order to backfill the settlement or any consolidation. And the third one is finishing. The vibrulence, it is removed and it moves to the next point. It's a short video in order to understand the Vibro compaction. You can see the vibrulence is penetrated into the soil. It vibrates and slowly it is moved to the surface, and backfilling is also done. After finishing, the Vibro compactor is moved to the next spot, and structure is standing on the soil. The second ground improvement technique is vacuum consolidation. It is a method using a K-pattage prefabricated vertical drain. It is used in a soft ground improvement method. A piece of prefabricated vertical drains are installed in the soil using a prefabricated vertical drain method. It is capped at the top and inserted in the soft seabed clay, and vacuum suction is applied to reduce the atmospheric pressure and pore water pressure. But eventually effective stress is increased accordingly. The airtight sheeting on the surface, it may be provided or it may not be provided, but the method, it is far superior to conventional methods in terms of cost effectiveness and labor saving. You can see in the picture that the drains are installed and above a layer of soil, it is also provided. This is the schematic diagram of vacuum consolidation. We can see the drain hose, the soft layer, the sealing layer, and the vacuum pump which vacuums the water, pour water from the soft layer. This is also a short demonstration of vacuum consolidation in order to understand it fully. Yes, the prefabricated drains are installed into the soft layer. These are some layers of sheeting and another soil for the settlement. The pour water is removed through vacuum pumps, and another soil layer it is installed to make it. Now the third one, it is preloading of soil. Preloading is an economical and effective soil improvement method that can reduce settlement and increase the bearing capacity of soft soil. Preloading accelerates settlement of the soil before the construction of the structure. It is effective for the soil having high moisture content, high compressibility, and low shearing strength. The most important and another advantage, it is remove the settlement that should otherwise be done after the completion of construction. These are three types of ground improvement techniques. Now I will leave the presentation to my other colleague, Ms. Zainab, to present its presentation. Thank you, sir.
हेलो रहीम, रेडी हो जाओ।
Okay, I'm sharing the screen. Okay, wait.
Kindly wait for a few seconds. My other colleague will present the other remaining parts of our presentation.
Hello, can I? Hello?
Yes, please.
Okay, sir. My topic is different kinds of ground improvement techniques. So, the one I'm going to present is soil rectification. This is the method in which we convert the waste into a glassy matrix so that residual waste will not leak out. It requires high temperature to melt the soil. First, we melt the soil by introducing the electrodes in the ground so that the soil melts. The melted soil is then refrozen into glass-like solid. Glass-forming additives are usually added to form the glassy matrix. Since the glass-like solid is chemically inert and has low leaching characteristics, it has superb performance in isolating the waste from the environment. In this technique, we just improve the ground which is which have waste materials. So in this process, we convert the waste into glassy matrix. In the figure, you can see the contaminated soil in which the temperature is increased by providing the electrodes to electric current, and the temperature is increased. So in that process, it melts and converted into the vitrified body, which is a form of glassy matrix. This is the gases. The next one is the ground freezing. It involves drilling and installing series of relatively close-spaced pipes and circulating coolant through these pipes. In this process, we freeze the ground. You can see in the figure the pipes are provided to freeze the ground. In this, the coolant is provided like nitrogen, etc. Liquid nitrogen. for freezing of the ground. The refrigerated coolant extracts heat from the ground, converting the soil pore water to ice, resulting in an extremely strong impermeable material. So this converts the pore water of the soil into the solid ice, which increase the stability of earth and make it impermeable. It is environment friendly method. So when the wet soil freezes, the water present in the soil is converted to the solid. That turns soil into the solid mass resembling concrete. It gains like the strength of concrete. Used in the construction of shafts, mines, and tunnels to provide temporary earth support and groundwater control when other conventional methods such as dewatering, shoring, and grouting are not feasible. So this is the process which we can easily provide through running the pipes in the ground. These could use can be environmental friendly glycols like calcium chloride brine or liquid nitrogen. This is the schematic diagram. The ground is prepared. In the first step, the ground is prepared for the pipes. This is drilling, and in this way, the liquid nitrogen in the pipes is passed to cool the ground.
Zainab, just to let you know, we are on slide 15 now.
Okay, so. Sir, can you see the slide 19?
Yes, now it's good.
The next one is the Vibro replacement stone columns. In this method, the densification is achieved by displacement of soil. In this, we first remove the soil, and then the stone columns are provided in the soil to compact it and give the strength to the soil. It can be both. It can be done by two methods: dry bottom feed method or wet top feed method. The one dry feed stone to vibrator tip through an attached feed pipe. In this, water is not involved, but just the stones are provided to the vibrator and the earth is compacted in this way. And in the wet top feed method, vibrator has attached water jet, and in this way we provide the stones and it produces a stone column in the presence of water. The Vibro replacement is most suitable for sand with a fineness content of more than 10% and usually less than 40% or for clays. It is designed for 45-meter or more depth. The next one is mechanically stabilized earth structure. In this, a retaining wall is built to stabilize an earth structure. It consists of alternating layers of compacted backfill and soil replacement reinforcement elements fixed to a wall facing. In the facing element, we provide precast concrete panels or wire mesh. They hold the soil between the reinforcement layers. Soil reinforcements are typically steel or geosynthetic fibers like polymeric materials such as rubber, etc. The stability of the wall system is derived from the interaction between the backfill and soil. So in this process, the soil reinforcements are provided, which are simply the geosynthetic members and or the steel members, and the backfill, compacted backfill. So in this way, the soil is kept.
Excuse me, sir.
Yes, please kindly click on slide 20 manually.
सर ये फुल स्क्रीन में चेंज नहीं हो रहा सर स्लाइड अगर ये इसी तरह कर लें
तो I'm on slide 19 now.
Sir, yeah. Can you see now?
Now it's good. Yeah.
Okay.
Please kindly click manually on the left side. Okay.
Okay. Here is a short video for the mechanically stabilized earth structures. You can see the The synthetic materials are installed in this and the backfilling is provided. The next one is the soil nailing. It is a technique used to reinforce, strengthen existing ground. It consists of installing closely spaced bars into a slope, in which we first excavate the soil to install a soil nail, and then grouting is done to hold it in place. And a wide mesh is provided to hold all the soil on one side to make a strength. Here is a short video for the demonstration of soil nailing. First we excavate that area, and then a steel nail is installed in this. And here is a steel nail. Micropiling. These are installed in the ground in sets at different angles to reinforce a mass of soil. This is mainly for the compression elements. It increases the compressive capacity up to 500 tons. The micropile casing generally has a diameter in range of 3 to 10 inches. It has a casing, and then the micropile is inserted in this casing. Here you can see the site where the micropiles have been installed, and here's a short video. These are inserted into some slope. There's a casing, and then we insert the bar. This is short grouting to hold the bars in place. And the plate. And then this one. The last one is the compaction grouting. It's use of mortar or concrete to laterally compact soils. In this, if the soil is have some voids, so we provide the concrete in the soil structure to gain the strength, to increase its bearing capacity. The injected grout pushes the soil to the side as forms a great column or bulb. In this way, it you can see in the figure the case drilling, and then in this the mortar is injected. So in this way, it forms a column of concrete which increases the bearing capacity or strength of the soil. The soil becomes increasingly dense as water or air voids are forced out of the soil structure. Here's the demonstration. Concrete is pushed into the ground in forms of bulbs, and it creates a column. There are some advantages like improve soft and compactable soil, stabilize or re-level existing structures, stabilize existing underground structures if we have already constructed a place, so we can also increase or stabilize it by injecting the grouts or by grouting, reduce water seepage and mitigate settlement. So here's the end of my presentation. Is there any question?
Okay, thank you very much, Anas Khan and Zainab. Two comments. Okay, first of all, the videos were interesting to all of us. The another one is that the allotted time was 10 minutes, so try to finish your presentations within the duration which is specified. So thank you so much, and if you need any extra marks in the sessional marks, or even if you both need any rechecking of your papers, and if there is 1 or 2 marks short by changing the grade, so I will try to help you, all of you. Okay, thank you very much. Salahuddin and Rahimullah, please
सर
continue with your presentation. Yes, please.
सर हमने तो मिलकर प्रेजेंटेशन बनाई थी, मतलब कुछ ग्रुप मेंबर्स का मसला था, नेट इशू था, तो और कुछ घर गए थे, तो इस वजह से प्रेजेंट नहीं कर पाए.
Okay, okay, I will note down their names as well. Thank you.
Sir, is Taran, please leave this
जी रहीम.
presentation. This is not our. This is not our slides.
सर हम अपना कल सर हमारा थोड़ा शॉर्ट है सर, 10 मिनट्स में हो जाएगा इंशाल्लाह.
रहीम
रहीम और
स्क्रीन शेयर.
सलाहुद्दीन ने रिक्वेस्ट किया था, रहीम और सलाहुद्दीन ने रिक्वेस्ट किया था सबसे पहले.
ओके
We will give them a chance. If they are not ready, then
यस रहीम स्क्रीन शेयर कर.
okay. Please, we are starting at 11:24 a.m. So try to finish it within 10
रेडी
minutes.
हो रहा है सर, अभी वो शेयर कर रहा है.
Screen.
ऊपर करो रहीम. जी जी.
Start.
सर स्टार्ट कर लो सर.
Yes, please kindly proceed.
Salam to all, and especially Sir Safdar Saab. Bismillahirrahmanirrahim. Starting with the name of Allah, who is most merciful in kindness and beneficial. Group member Rahimullah, Salahuddin, Talha, Muhammad Akif Khan, Sayyid Wajat, Ilisha, Ahmad Shehzad. आगे करो रहीम. हमारा जो प्रेजेंटेशन टाइटल है वेरियस ग्राउंड इम्प्रूवमेंट टेक्निक्स यूजिंग इन जियोटेक्निकल इंजीनियरिंग, यानी ग्राउंड इम्प्रूवमेंट के लिए, सॉइल इम्प्रूवमेंट के लिए जियोटेक्निकल इंजीनियरिंग किस तरह इम्प्रूव करेगी. फर्स्ट ऑफ ऑल इंट्रोडक्शन. ग्राउंड इम्प्रूवमेंट रेफर टू टेक्निक डेट improve the engineer property of soil mass treated, usually the property that are modified: shear strength, stiffness, permeability. Ground improvement has developed into spaghetti tools, yani advanced modern tool to support foundation for wide variety of structure. Main improvement techniques एक होता है temporary IG, for example dewatering or water freezing, where the improvement is only during the application. Short term IG, for example some form of the grouting or using diaphragm wall for siege of construction with long term benefit. Long term IG, soil nailing, vibro replacement, certain grouting of the dam, where treatment is integral to the permanent work. For further presentation invite Rahimullah. जी रहीम आगे प्रेजेंट करो.
Bismillahirrahmanirrahim. The main improvement techniques include vibration techniques, loading addition techniques, structure reinforcement technique, and structure filling techniques by grouting. Also, improvement techniques including. First of all, Vibral Compaction is also known as Vibral Flotation for ground improvement. Vibral Compaction is a technique in which the density of granular soil are increased by the insertion of a heavy vibrating poker to a desired depth for the depth up to which we require the compaction. It is one of the most common ground improvement techniques using vibration. Water flushing is done during the insertion process. During the insertion of the poker, we use the water flushing. Vibro flotation is most suitable for very low sand submerged under water table. The sand which are submerged under water table, their vibro flotation is the most suitable. Efficiency of this densification reduces with the increase in silt and clay content, and penetration rate reduces in case of descent with deep water tables. These are limitations, various limitations occur in the Vibro Compaction. Number one, Vibro Compaction is not effective where the fines means the silt and clay exceed 20%. Where the silts and clay are present 20% or more, the Vibro Compaction is not effective. Coarser grain limit is applicable to Vibro Compaction, and Vibro Compaction is not used in permeable soils. Vibro flotation was first used in the structural leisure fines. These are the application of Vibro Compaction. Vibro flotation was first used in the saturated natural fine sand application of Vibro compression. Some of these applications, it is applied to improve hydraulic fields. Vibro flotation reduce risk of liquefaction during seismic events. Vibro compaction is used our water. It is used our depth of 30 meter can treat it, and it can up to about 50 meter. We can also apply. Multiple vibrators can be coupled together in a group. Vibro compaction is used in a conjunction with surcharging. This is an animation which you can clearly see in the animation a vibrator poker is drained inside the soil and the vicinity when created inside the soil, then the soil is again damped and make it denser. So this is one of the type of soil compaction and soil improvement technique. And this on the after compaction, a foundation is laying on this. Now this is a figure in which Vibro Compaction technique is shown. Now it's Akib turn. I'm inviting Mr. Akib to present further. Akib.
Thank you, Rahim. Yes. Bismillah ar-Rahman ar-Rahim.
Please continue.
Yes. Dynamic compaction. So it is actually an effective, efficient, and cost-effective soil improvement technique that uses dynamic effect of high energy impacts to densify weak soil. Rahim, I can't see the screen clearly.
Rahim, please turn off your mic.
So, in this type of compaction, heavy weight is dropped onto the ground surface. So, it is not suitable for adjoining buildings because vibration impact can impact adjacent buildings or building surface onto the ground. And this type of technique, specialist rig, tractor or truck is used to reduce noise and environmental disturbance. And the dynamic compaction involves the repeated dropping of a large weight of 15 tons or so from a height of up to 50 meters. The site is usually covered at first with a wide grade, followed by a smaller grade using a lighter weight or a reduced fall. And this technique can effectively compact the ground down to a depth of a few meters. It is not suitable for small sites or sites where vibration impact can affect adjacent buildings or building service in the ground. Here are some pictures of the dynamic compaction through which dynamic compaction is done. And the advantages of the dynamic compactions are they are cost effective. It densify and compact soil to a depth of 12 meter, and it improves the bearing capacity of soil. This was all from me. I would like to invite Sayyid Wajahat Ali Shah to proceed further.
Thank you, Akib. Bismillahirrahmanirrahim. Now I will proceed further with the reinforced earth. Reinforced earth is a combination of earth and linear reinforcing strips that are capable of bearing large tensile stresses. Means these reinforcing strips increase the tensile stresses of the soil. The reinforcement provided by these strips enable the mass to resist the tension in a way which the earth alone could not. And the source of this resistance to tension is the internal friction of soil. Because of the stresses that are created within the mass are transferred from soil to the reinforcement strips by friction. As we will see in further, uh, like in soil, it should be the soil properties are that they should be granular, cohesionless material should be used, and not too much silt or clay that is having a particle size of less than 120 millimeter, and also not more than 10% of the particle shall pass 75 micron sieves, and the earth reinforcement coefficient of friction should be higher than or equal to 0.4, and plasticity index should be less than 6. These are all the properties of soil that should be used in especially in the abutment walls in which the soil is to be filled. The soil must have a moisture content suitable for the compaction. So in reinforcement, a variety of material can be used as reinforcing materials. It can be steel, concrete, glass fiber, wood, rubber, or aluminium. And the skin in the facing element of the reinforcement soil wall. These elements keeps the reinforcement at a desired elevation in the reinforced soil wall and also protect the granular edge from falling off. As we can see the abutment walls. So whenever abutment walls are created and there is uh, the wall is large enough and this is a slopy wall. So we use abutment walls uh, and we densify the soil by these uh, tensile increasing geopolymers. Next, we will see some animation. Here is the retained soil and at the base there is foundation. First we will use the geotextile and then we will use some bricks, and the dark black as shown in the figure are the geopolymers. So we will make these geopolymers step by step and we will fill it with granular soil. Similarly, by increasing the depth, as here is the sloping ground and we have the foundation, we have to densify it. So we will use the compacted soil, granular soil, and we will use geopolymer step by step to increase the height of the size of the wall, the height of the wall. And these are mostly used in abutment walls. Beside the abutment walls, we use these type of soil improvement technique. Thank you. Now I will invite next participant to please proceed further.
Thank you, Wajat Alisha. So my topic is about blasting. Blasting used for the densification of a granular soil. Detonation of explosive charge such as 60% dynamite at a certain depth below the ground surface in a saturated soil. The lateral spacing of the charges varies from 3 to 10 meter, 10 to 30 feet. 3 to 5 successful detonations are usually necessary to achieve the desired compaction. Compaction up to relative density of about 80% and up to a depth of about 20 meter 60 foot over a large area can easily be achieved by using this process. The explosive charges are placed at a depth of about 2 by 3 radians of the thickness of the soil of layer desired to be compacted. So this animation, the compaction of a soil deblasting. Air blasting is detonation. I would like to invite the other participant to continue the further slide.
Thank you, Muhammad Talha. Bismillahirrahmanirrahim. The topic is permeation grouting. Permeation grouting, also known as cementing grouting or pressure grouting. It builds cracks or voids in soil and rocks and permeating coarse granular soil with flowable particulate grouts to create a chemical to create a cemented uh, mass. It helps the commonly used is create barriers to ground water flow, underpin foundation, provide excavation support, and also stabilize and strengthen granular soil. Next. Rahim, next one. Process. The process of permeating grounding, depending on the condition, for lead cement or micropine cement grout is injected under pressure at strategic location through single port or multiple port pipes. The grout particle size and wide size must be matched properly to allow the cement grout to permeate. This ground mesh has an increased strength, stiffness, and reduced permeability. And the main purpose of this is to avoid porous or voids from the inner grounding surface. Next one. Advantages. The main advantages of permeation grouting is to help strengthen sand and gravels and repair structural permeation. The process produce a solidified mass to support increased load and fill voids in the soil. It always allows you to maximize the footprint of excavation compared with pile solution. It can be done with access is difficult and space is limited. The sense effectiveness of permeation grouting is independent of structural connection, so it is readily adaptable to existing foundation, and it typically be accomplished without disrupting normal facility operation. Next one. Depending on the condition for now come. Depending on the condition, Portland cement or micropine cement grout is injected under pressure at strategic location. ये repeat हो रहा है Raheem. Next one. Now this is the video related to permeation grouting, and concrete is pillars pushing into the grounds, and
Go to next slide, please.
It's thank you.
Okay,
सर
so
हम लीव कर सकते
presentation.
Okay, Wakas, please share your screen.
Hello, Assalamu alaikum.
वालेकुम सलाम.
Sir, start करें. Assalamu alaikum. So my name is Ahsan Shahid, and
just wait a moment. Okay, please, the time is 11:42 a.m. Try to finish it within 10 minutes. Thank you.
okay, sir. Thank you. My name is Ahsan Shahid, and I'm going to be presenting you today the topic. So my group members are Waqas, Murtaza, Sudais, Ahsan, Abdul Alim, and Irfanullah. Next. So the contents are introduction to soil compaction, compaction effect, three-phase diagram illustration, compaction techniques for shallow soil region, compaction techniques for deep soil region. So, introduction to soil compaction. In geotechnical engineering, soil compaction is a process in which stress is applied to soil, causing densification as air is displaced from the pores between the soil particles. Akash, next. So let us talk about the history of various development made in ground improvement. So do you know about the Manard Group? Manard Group of members are specialists of geotechnical engineering who worked on various ground improvement techniques. This group was started by the inventor Louis Manard in 1954. Also in 1954, he was in the invention of pressure meter, also known as the Manard pressure meter, which is used to find the ultimate pressures of soil and its deformation modulus in order to calculate the bearing capacity and settlement. In 1957, he started a company known as Manard Pressure Meter, who manufactured and distributed the tool around the world. In 1968, he was an invention of dynamic compaction for sandy soils, and in 1969, he did a project on this in Naples, France. This was the largest project in the dynamic compaction. He built and used custom-made massive machines. In 1954, he developed CMC's control modulus columns. Control
Waqas, please
modulus
can you go
column.
to the next slide?
Yes, sir. Uh, Okay, control modulus columns are concrete columns placed in a network adapted to loads and settling criteria, combined with a granular bed. This distribution bed spreads the applied load between the ground and the CMC. So this was all about the modern era of the ground improvement in geotechnical engineering. Let's go to the main part of the presentation. So compaction effect, you can clearly see water and air. In the next diagram, it is compacted and the air is less over there. Akash, next, decrease. Three-phase diagram. So from here, so this will continue. So this, thank you.
Thank you, Hassan Shahid. Okay, so Waqas next. Okay, so now we will move on to the main part of the presentation. So first of all, we will discuss some of the improvement techniques which can be used for shallow layers of soil. So mainly the shallow compaction is done in either static way, which is done with the help of mechanical loading, or we can use the dynamic procedure where we use vibrations, or we can also use stamping. Okay, so for a shallow compaction, we have the following tools. First of all, we have different rollers, such as smooth wheel roller. Then we have the sheep or pad foot roller. Then we have the damping roller. Then we have the rammers and the vibratory plates. Next. Okay, so here is the pictorial representation of different instruments or equipments which are used for the shallow compaction. On the left hand side, you can see the self-propelled pipes in the form of a pneumatic roller, smooth roller, sheep foot roller. You can also see the handy compacting tools, the tools which can be operated using hands, such as vibrating plates and rammers. Then on the right hand side, we have the tout rollers, the different form of tout rollers. Next. Okay, so first of all, we will start with the smooth wheeled compaction rollers. As you can see from the name, the smooth wheel roller will have huge drums, and the surface of those drums will be smooth. So basically, what the process is, these drums have a certain amount of weight, and when we roll it over the soil gets compacted. So this is a simple basic procedure behind the smooth wheel compaction. These are either tandem or two wheels or three wheels or rollers, and these are basically ideal for gravel, sand, ballast, or surface dressing. So basically, we use it for gravel, sand, ballast, for coarse aggregates mostly, and these are also very effective in case of silty and sandy soil. In the case of smooth wheel rollers, we can either have compaction with the help of a static load, as I already defined the procedure, or we can also have a dynamic loading in the form of vibration. Next. Okay, so here you can see the pictorial representation of a static of a smooth wheel roller. We can either have a static roller and we can have a vibratory roller. You can clearly see that both of these rollers have two wheels at the rear, and we have a big, huge weighted drum at the front with smooth surface. So that's how you can identify these rollers. Next. The next technique which can be used for the soil compaction is by using a sheep foot roller. So what a sheep foot roller is, it again has a huge drum, but in this case the drum has lugs, or what do we call it? It has spikes, yeah, spikes or lugs coming out of it, and due to which we can get some more pressure on the soil. So the compaction of soil in this case is mainly due to these lugs penetrating inside the soil, and in those contact regions maximum pressure is applied. Sheep foot rollers are used in case of fine-grained soils. So whenever we have a scenario of fine-grained soils, such as in embankments, dams, etc., we will go for the sheep foot rollers. Sheep foot rollers can again be either static or vibratory. Next. Here again we have the pictures for sheep foot rollers. In both these pictures you can see the spikes coming out of the drum, which help to compact the soil better. Next. Okay, now we have the third technique, or the third instrument, which gives us the third technique for the compaction of soil. Basically, the pad foot is a combination of the sheep foot and the damping roller. So in simple words, what pad foot is roller compaction is that at the front it has a tamping machine which tamps the soil, and then after the tamping machine we have a sheep foot. So the static pad foot roller is also called a tempo roller, have a static weight in the region of 15 to 40 tons, and the static linear drum loads are between 30 to 80 kg per centimeter. So you can see it has quite a huge weight. So first of all, the surface is compacted by tamping, as I already said. Then the sheep foot comes into the drum. The degree of compaction is achieved more than the sheep foot because we have huge static weights, and we have two processes occurring, the tamping and the rolling. So here we'll have more compaction. Also note that the soil compacted will be uniform in this case. So this technique is comparatively better than the previous two. These rollers also have, it can have leveling blades to spread the material.
So there's just to let you know that we are on the slide number 15.
Okay, sir. Okay, sir. Okay, so next focus. So here is the example of a pad foot roller. We have a tamping machine at the front, then we have the sheep foots. Next. Okay, now we have a rammer compaction. So basically, a rammer is a handy tool which can be operated with the help of hands. It is a lightweight compacting equipment, so we can use it in the small areas. So this compaction equipment is light and hand operated, as I already stated. Rammers are mostly suitable for cohesive and semi-cohesive soil. Then we have the dimensions. It can either come in the base can be of 15 to 15 centimeter or 20 to 20 centimeter. And then we have its weight can vary from 30 kg to 10 tons. Next. Here you can see video representation of the rammer compaction. Okay, next. And last but not least, in the case of shell foundation, we have vibratory plate compaction as well. As you can see, this again is a handy instrument we can operate it with the help of our hands. So these are used for compaction of basically coarse soils having 4 to 8% fineness. These equipments are used in small areas, the same as that of rammers. Then we have the usual weights of these machines, which can vary from 100 kg to 2 tons. So it is quite heavy. These compactors have plate areas between 0.16 to 16 meters square. Next. Okay, so here again we can see the process of vibratory plate compaction. Next. This was all from my side. Now I'd like to pause Wakas to further continue with the presentation.
Thank you, Sudesh. Sir, is my voice audible to you, sir?
Yes, it's clear, and the screen is also clear. Okay.
Thank you,
Please
sir.
try to finish as soon as possible.
So my topic is improvement techniques for deep layer of soils. There are various improvement techniques for deep layer of soil, of which I will discuss only pre-compression or preloading, heavy tamping, compaction grounding, vibro compaction, and vibro replacement. So what is pre-compression? So the basic principle of pre-compression or preloading is that to compact a soil layer, a deep soil layer, we put a surcharge or preload on that soil so that appreciable settlement takes place and the water is drained. So after the water is drained and the compaction takes place and the settlement takes place, we then proceed with the construction of a structure. Due to this technique, we remove the water from the soil and also improve the stability of the soil. Purpose of removing water from the soil is to prevent unusual settlement of soil, because without water removal, structure on that soil can be fatal settlement and deformation. Like you can see the live example of Leaning Tower of Pisa. Here is a pictorial representation of a surcharge of preloading. A surcharge weight is placed on the soil layer and slow drainage takes place. And after the settlement, a structure is being constructed on the soil layer. So there are two ways to perform the preloading technique, which is the first one is without vertical drainage system and the second one is with vertical drainage system. So in the first method, the vertical drainage system is not taking place, while in the second step, the vertical drainage is taking place. Now the second improvement technique is heavy tamping. As the name suggests, we have to lift the hammer at a certain height, and then we have to subject the hammer to free fall motion, and due to the impact of the hammer and the soil layer, compaction takes place. This technique can compact the surface up to 10 meter depth. So this is the surface up to which this compaction technique can take place, which is 10 meter. Here is the picture of the pictures of some heavy tamping which are occurring at the sites. Here are the stages of the heavy tamping. So the first step is that the surface is compacted with repeated blows. As I discussed earlier, the hammer is lifted at a certain height and then subjected to free fall, and the impact between the soil and the hammer compact the soil in turn. Next step is filling the compacted surface. So as you can see in the previous slide, due to compaction, certain deformations are taking place in the soil. So we have to fill that with the compact filling. Filling is being done with the soil so that the surface is even out. Then ironing the surface is taking place. The compacted surface is then further compacted and leveled to the blows of iron plate on the surface. And then roller compaction is taking place. Here is the animation showing the live video of tamping. As you can see, the hammer is lifted and then pre-fall motion takes place. Next, we have compaction grounding. So we can also compact the soil by injecting a concrete of slow slump. Low slump means that the workability is low and the strength of the concrete is high. So we inject or penetrate the jet into the deep layer of soil, and then we inject the compaction, the concrete grout, which in turn increases the density of the deep layer of soil and increases the stability of the soil. Here are the steps showing the compaction grouting. So as I discussed earlier, first step is drilling with casing. The drill is penetrated within the layer of soil and then extracted. While extraction, the grout is simply injected into the soil, as you can see here. Here is the animation showing this procedure. First, the drill is injected deep into the soil layer, and while it is extracted from the soil, the grout is simply placed in the soil layer. Next up, we have Vibro Compaction. As the name suggests, we have in this method, the vibration is taking place. We have to inject certain instrument inside the layer of soil, and we have to vibrate the soil beneath to compact the soil. This compaction is attained by using depth vibrators or vibrofloat. So the instrument which is injected inside the deep layer of soil is depth vibrators or vibrofloat, which is suspended from a crane or mounted on a pilling equipment. This process occurs at different location of the surface area to compact the surface as a whole. So here are the stages of Vibro Compaction. As I discussed earlier, first penetration of the vibrofloat or the vibrator takes place. So we have to inject or penetrate the vibrator inside the layer of soil. Then we have to vibrate the soil beneath, and we have to backfill the soil which has come out or extracted onto the surface due to compaction due to vibration. This process continues until the whole board area is filled with the sand to compensate the volume of soil. So the volume of soil which is displaced is in the end put back into the soil layer. Here are the steps showing the Vibro Compaction. So first it is injected into the soil layer, then the soil layer is vibrated, and then while extraction, the soil which has been displaced is put back into the soil layer. Here is an animation showing this process. It is injected into the soil, and the backfill material is put into it. As it is extracted, the backfill is put back into the soil. Next and last improvement technique is vibro replacement.
Because just to let you know, we are on the slide number 36.
So this is the last topic, sir. Vibro replacement. Vibro compaction. Vibro replacement is a ground improvement process where vertical columns of stones or aggregates are formed to the soil for the improvement and a compaction of soil. The picture image is showing this process. The instrument is injected and the vertical column of stone or aggregates are formed in the soil layer. What is the mechanism of the vibro replacement? So first off, the vibrator is penetrated as shown in the image earlier. The vibrator is penetrated to the soil at some depth with or without using the water pressure jet system. So the water is injected to make the penetration of the instrument easier. Gravels or aggregates are then added in a penetrated bore, and repeated penetration of vibrator or aggregates results on the aggregate being pushed into the soil, which in turn increases the shear strength of soil and compact the soil. This process continues until the whole penetrated area is covered with compacted aggregates, thus forming the stone column. At last, the proper finishing of the upper surface is done. Thank you. Any questions?
Thank you very much, Waqas.
Thanks.
Only one comment. It went a bit longer than expected. Okay, so the emissions were amazing. They were really interesting. Actually, that's why I left it to went beyond the duration which we decided, that maximum 10 minutes. And for the coming presenters, please kindly try to keep your presentations within that 10 minutes duration. It will help all of us to, just to concentrate on what you are saying and what you are presenting. So thank you so much. Who is the next presenter, please?
Sir, I wanted to represent.
Okay, Zar, you can continue. Please, 10 minutes maximum, okay? Please write in the comment box. Don't write too many comments there. Just write that who is going to present next. That's it.
Can you see the slides?
We are waiting for it.
Okay.
Please share your screen. Yeah. Now it's good.
Now you see the slides.
Yes, we are starting at 12:04 p.m. So please kindly finish it within 10 minutes. Thank you very much.
Inshallah, I will try to finish it in within 10 minutes. Assalamu alaikum, everyone. First of all, I will thank Dr. Saif who gave us opportunity to present the topic. The topic is compaction technique used in the field for shallow and deep soil layers. My group members are Adil Khan, Nizar Ahmad, and Zaur Khan. First of all, I will say something about the compaction. Actually, what is the compaction? In geotechnical engineering, soil compaction is the process in which stress is applied to the soil and causes infection as air is displaced from the pores between the soil grains. Stress is applied that causes infection due to the water and other liquids being displaced from between the soil grains. Then consolidation, not compaction, has occurred. Need of compaction. Soil compaction needs in a varieties or various projects which we will increase the bearing capacity of the soil due to the compaction as a loose soil. We make the compaction of that in order to enhance the bearing capacity of the soil. It is used for the support of the structural entities such as a building, foundation, roadway, walkways, and earth retaining structure. For a given soil, type certain properties may be deemed it's more or less desirable to perform adequately for a particular circumstances. These are the picture in which you can see the soil compaction of loose soil compaction in order to enhance their required bearing capacity. Different type of soil compaction equipments. The soil compaction equipments can be divided into two groups, mainly light soil compaction equipments and heavy soil compaction equipments. Light soil compaction equipments. These equipments are used for soil compacting of a small area only and where the compaction effect needs is less. Below are light equipments for soil compaction. Below are the light equipments for the soil compaction. Rammer. Rammer are used for a for compacting small areas by providing impact load to the soil. This equipment is light and can be handed or machine operated. The usual weight varies from 30 kg to 10 tons. These hammer within 2-3 tons. Weight are allowed to free fall from a height of 1 meter to 2 meter on the soil for the compaction of rock fragments. They are the hammer. Vibrating plate compactor. Vibrating plate compactor are used for the compaction of a coarse soil with 4 to 8% fine. These equipments are used for a small area. The usual weight of these machines are vary from 100 kg to 2 tons with a plate area between 0.16 meter square and 1.6 meter square. They are vibrating plate compactor. Vibro temper. Vibro temper is used for the compaction of a small area in the confined space. This machine is suitable for the compaction of all type of soil by vibration set up in the base plate through a spring activated by an engine driven reciprocatory mechanism. They are usually manually guided and weighed between 50 and 100 kg. They are vibro temper. Heavy soil compaction equipment. These compaction equipment are used for large area for the different type of soil. The heavy compacting equipments are selected based on the moisture content of the soil and the type of soil. These are the following or the some equipments used for the heavy soil compaction equipment. Say heavy soil compaction. Smooth wheel roller. Smooth wheel roller are further two types: static smooth wheel roller and vibrating smooth wheel roller. Static smooth wheel roller. The most suitable soil for these roller type are well graded sand, gravel, crushed rock, and asphalt. Where crushing is required, these are used on the soil where does not require a great pressure for the compaction. These rollers are generally used for finishing the upper surface of the soil. These rollers are not used for the compaction of uniform sand. The performance of smooth wheel roller depend on the load per centimeter weight it transfers to the soil and the diameter of the drum. The load per centimeter weight is derived from the gross weight of the drum. They are the static wheel roller. Vibrating smooth wheel roller. In case of vibrating smooth wheel roller, the drum are made to vibrate by employing rotating and reciprocating mass. These rollers are helpful from several considerations like higher compaction level can be achieved with the maximum work. Compaction can be done up to the greater depth. Output is many times more than the conventional roller. And they are the vibrating smooth wheel roller. Sheep foot roller. Sheep foot roller are used for the compaction of for compacting fine-grained soil such as heavy clay and silty clay. Sheep foot roller are used for the compaction of a soil in dams, embankments, subgrade layers in pavement and railroad construction projects. Sheep foot roller are of static and vibratory types. Vibratory types roller are used for the compaction of all fine-grained soil and also soil with a sand gravel mix. Generally, this roller is used for the compaction of subgrade layer in a
Nizar,
road.
please kindly go to the next slide.
Pneumatic tire roller. नेक्स्ट स्लाइड पे हो गया सर. हेलो सर. हेलो
जी निज़ार आपकी आवाज़ आ रही है.
चौधरी साहब नेक्स्ट स्लाइड हो गया है कि नहीं?
जी हाँ हाँ हो गया निज़ार भाई. सही है.
Okay. Okay. Pneumatic tire roller. Pneumatic tire roller are also called rubber tire roller. These rollers are used for the compaction of coarse grained soil with some fines. These rollers are least suitable for uniform coarse soil and rocks. Generally, pneumatic tire rollers are used in pavement subgrade works, both earth work and bitumen work. Pneumatic rollers have wheel on both axes. These wheels are straight for the compaction of a soil layer with uniform pressure throughout the width of the roller. The factor which affect the degree of compaction are tire inflation pressure and the area of the contact. Grade roller. Grade roller are used for the compaction of weather rocks, well-graded coarse soil. These rollers are not suitable for clayey soil, silty clay, and uniform soil. The main use of these rollers are in the subgrade and subbase in the road construction. As the name suggests, these rollers have a cylindrical heavy steel surface consisting of a network of steel bars forming a grate with a square holes. The weight of the roller can be increased by blasting with the concrete blocks. Paired foot tamping roller. These roller are similar to sheepfoot roller with legs of larger area than the sheepfoot roller. These rollers are more preferable than the sheepfoot roller due to their higher production capacity and they are replacing sheepfoot roller. The degree of the compaction achieved is more than the sheepfoot roller. The density of a soil achieved after the compaction with this roller is more uniform. These rollers are operate at a high speed and are capable to breaking large lumps. These rollers are also consist of leveling blades to spread the material. Thank you. I haven't had any
So,
animation, sir, due to the internet issue.
yes, that is missing in your presentation, which was, which can add value to your presentation as well. But as a whole, you started your presentation well and you finished within your set duration, which was 10 minutes. So thank you so much for that. So who is next, please?
Thank you, sir.
मैं हूँ सर नेक्स्ट.
Muhammad Ibrahim, right? Who has raised hand?
मैंने रेस
Ibrahim.
किया सर.
Okay, so you're already talking, so that's fine.
ओके
Please,
सर.
can you share your screen?
ओके. Can you see my screen?
Yes, it's visible.
Okay, sir. My voice is clear, sir.
Yes, it's clear.
Bismillah ar-Rahman ar-Rahim. First of all, I would like to thank Dr. Saab for giving us the opportunity to present this topic. My group members are Shapad, Ijaz Ali, Atif Ali, and me. The topic of our presentation is various techniques used in the field for improvement of shallow and deep soil layers. Our main topic was improvement of ground, but we have categorized the ground into shallow and deep soil layers. First of all, we will discuss what is the compaction of soil. In geotechnical engineering, soil compaction is the process in which the stress applied to a soil causes disinfection as the air is displaced from the pores between the soil grains. As you can see in the diagram, the particle of uncompacted soil are given and the compacted are also given. In compacted soil, the air is removed from the soil particles. What are the main purposes of compaction? To improve the engineering properties, that is, to improve the shear strength, to improve the density, to improve the bearing capacity, to reduce the permeability, to reduce compressibility, and to reduce the shrinkage of soil. First, we will discuss shallow soil layer compaction. The soil compaction equipments can be divided into two groups: heavy soil compaction equipments and light soil compaction equipments. Heavy soil compaction equipments. These compaction are used for large area for different type of soil. The heavy compaction equipment are selected based on the moisture content of the soil and the types of soil. It also depends upon what type of compaction we need. Following are different types of these equipment. The first equipment is smooth wheel roller. A smooth wheel roller is generally consists of three wheels as shown in the diagram. We can see there are two small wheels in the rear and one wheel in front. These rollers are used in a soil which does not require great pressure for compaction. These rollers are generally used for finishing the upper surface of the soil. The main feature of these smooth wheel rollers are they have weight from 2 to 15 tons and they cover the 100% land under the wheel and large contact area. They cause less pressure 300 to 400 kPa. These are suitable only for a thin layer compaction of well graded lands, gravel silts, and clays of low plasticity. The second sheep put rollers. This roller is similar to smooth wheel roller, but in the case the front wheel have numerous projecting feet with a length of 200 to 250 millimeter and have area 40 to 65 centimeters square. As you can see in the diagram, there are spikes. These rollers are used for the compaction of soil in dams, embankments, subgrades layer, in pavements and railroads. The main features of this sheep put rollers are it cover 8 to 12% of the land under the wheel. They don't cover the whole area because of the spikes. It's the coverage area is less, so it have a high contact pressure. Suitable for fine grained soils, sands, and gravel with more than 20% fines. Unsuitable for coarser soil and uniform gravels. The third is pneumatic rollers. Generally, pneumatic rollers are used in pavement subgrade work, both earthwork and bituminous work. The main feature of these pneumatic rollers are it consists of 7 to 13 wheels, and it covers the 80% of the land under the wheel. The coverage area is less, so it have a high contact pressure 700 kilopascal, suitable for both coarser and fine soil. These pneumatic rollers are unsuitable for very soft clay and highly variable soils. The last one is grid rollers. These rollers have a cylindrical heavy steel surface consisting of network of steel bars forming a grid with the square holes. As you can see in this picture, there are clearly grid on the surface of this roller. These rollers provide high contact pressure but a little needing action. These rollers are used for compaction of hello.
इब्राहिम आपकी आवाज आ रही है?
Why?
Someone,
इब्राहिम आपकी आवाज आ रही है लेकिन निजार भाई ने शायद प्रेजेंटेशन ओपन कर दी थी।
अब मेरी स्क्रीन नजर आ रही है आपको?
जी अभी नहीं आ रही है इब्राहिम भाई।
स्टॉप कर लो तो फिर दोबारा शेयर।
Okay, I will present again.
आया सही दे।
Yeah, man. अब स्क्रीन नजर आ रही है मेरी?
जी इब्राहिम भाई अब
Now the second is light soil compacting equipments. These equipment are used for soil compacting of small area only and where the compacting effort needed is less. Following are the light equipment for soil compaction. First is rammers. As you can see in the diagram, it is used for very small area. Rammers are used for compacting small area by providing impact load to the soil. This equipment is light and can be hand or machine operated. Rammers are suitable for compacting cohesive soil as well as other soil. These are used in the area with difficulty in access. As these are also used in the area where heavy machinery is not accessible, so we can use rammers. Unsuitable for large volume because it will take a lot of effort to cover the large volume with this rammers. The second is vibrating plate compactors. Vibrating plate compactors are used for a compaction of coarse soil with 4 to 8% fines. These equipment are used for small areas. The usual weight of these machines vary from 100 kg to 2 ton, with the plate area between 0.16 meter square to 1.6 meter square. Now, the second layer which we discuss is a deep soil layer compaction techniques. This is the deep soil layer compaction, so it requires more accurate and more uneconomic techniques. So the first one is pre-compression. In this method, the site is preloaded on the groundwater level, or groundwater level is lowered, causing the soil to consolidate. This is the long-term consolidation of soil. After restoring original stress levels, the future structure built on this site settle less than those on the untreated ground. This technique is mainly used for cohesive soil. The second technique for deep soil layer compaction use is heavy tamping or dynamic compaction. A large mass is dropped into the ground surface, causing compaction and long-term consolidation. Usually, the weight is 10 to 50 tons and the height is 10 to 40 meters. And the compaction depth depends upon the load and the intensity which are we dropping this, and the height from which we are dropping this. This heavy tamping or dynamic compaction can be explained through this animation very well. So I will play this. This is the load and 30 to 40 meter height, and we drop it. The soil, you can see this is compacted. It depends upon the nature of the soil, the compaction. The, the next technique used is Vibro Compaction. Vibro Compaction is an established ground improvement method for stabilizing granular soil such as loose sand, gravel, and some hydraulic pills. The technique is primarily used for seismic mitigation and in situ disinfection of loose sand up to 30-meter deep. The technique used in a vibro plate is penetrated into the required design depth, assisted by water jetting from the nose cone. Upon reaching design depth, water jetting is reduced before the vibro plate is slowly extracted, with deposit at regular interval to ensure satisfactory levels of compaction are achieved at each depth. Additional site one sand may also be added at the top of the hole in order to fill the cone of the depression is that formed. This can be explained by this animation. This is a water jet we were talking about. Now the aggregate and pour into it, and then it is compacted.
Okay, Ibrahim, please kindly go to the slide number 20.
Okay, sir. So the last techniques used for deep soil layer compaction is stone column. A suitable technique for ground improvement for foundation on soft clay is to install the vertical stone column in the ground. In this method, a soft cohesive soil is replaced by compacted stone in a pre-bored vertical hole within the soil. There are two advantages in function of this stone column. They provide reinforcement to the soil and allowing further consolidation under any given load. Here is a short video. I will play this for a few seconds. This is a column boring, used for boring. Now the aggregate is poured into it. So the aggregate are compacted in this way, and the final surface of these stone column after installation look like this. So this was all from my side. If you have any question, you can ask.
Thank you
Thank
very
you.
much, Ibrahim. I really enjoyed your videos and those animations. Those were really interesting. Uh,
Thank you, sir.
yeah, okay. Who is next, please?
सर मैं प्रेजेंट करूँ सर
Ashad Zawar Khan. Please kindly share your screen and Waqas Khan has raised a hand. Waqas, what you want to talk, please?
No, sir.
Okay. So, Ashad Zawar Khan, please can you share your screen? The time will start at 12:28 p.m. Click on the presentation, yes. 44 slides. So you need to be a bit quicker in your intro. Please kindly go to the animations there so you can spend a few minutes over there. The time will start at 12:28 p.m. Okay, go ahead, please.
Bismillahirrahmanirrahim. I'm Ashad Zawar Khan, student of Civil Engineering Department, UT Peshawar. First of all, I am very thankful to Sir Dr. Mohammed Sabdar, who gives us an opportunity to present a topic to groom our skills for 3MTC. So my group members are Zahid Islam, Muhammad Rafi, Amir Khan, Ishtaq Ahmed, and Niharullah. The topic of our presentation is ground improvement techniques which are used in the field to improve the soil, the ground. What are the table of contents? So I will be trying to cover the ground improvement. What are the different techniques of ground improvement, and what are the objectives of ground improvement, and some certain factors that affect the ground improvement. So the objectives of today's presentation is to understand the different techniques which are used in the field for improvement of ground. So these techniques will be discussed in the next slides. So first of all, what is ground improvement? Ground improvement is the application of various geotechnical techniques that are used to improve the engineering characteristic of pre-existing soils. By this sentence, it means that, for example, if we have soil and after testing the criteria which we have studied up till now that are bearing capacity load criteria, settlement criteria, and the third one is overturning criteria. So, for example, if we test the soil and these criteria are not fulfilling, so what we can do is we will improve the ground. So in order to fulfill the criteria, and we design that for the required loading and not exceed the required settlement. So this is the main purpose of ground improvement. Ground improvement may be site stabilization, vibro stone column, jet grouting, deep soil mixing, and dynamic compaction. The objectives of ground improvement of refill and excavation are avoid adjacent to structure to provide support structure a structure is so excavation like you are excavating for foundation. So in order to so if we want that they should set what do we next and reduce permeability. So we stability and permeability is the density. These are the main objectives of ground improvement. That's why we are going to improve our ground. Hello.
Yes, it's clear now. Ashad, now it's clear. Please continue.
Hello.
Ashad, please continue. Yes, it's clear.
So it was clear, sir. the factor affecting ground that are type of structure to be constructed on the improved soil. Like if we are constructing tall stories, it will require from the time actions available of materials present vacuum consolidation.
Who is the next presenter, please? Who is the next presenter, please? Hezbollah, please kindly share your screen. Okay, he's back, so let's wait for him. Ashad, please can you click on the PowerPoint presentation? Please
Sir, sorry for the interruption. पता नहीं
No
आज क्या
problem.
मसला है नेट में.
No problem. It's okay. Please continue.
Okay, sir. Sir, कहाँ से मैं डिस्कनेक्ट हुआ था?
Yeah, here.
Okay, so अभी मेरी वॉइस क्लियर है सर?
Yes, it's clear.
Okay, so the first one is vacuum consolidation. So I will not be doing an explanation of this, so I will be explaining the diagram. So what is happening in the diagram? What is happening in the vacuum consolidation? That we provide a vacuum pump which creates negative water pressure in the water through the provided drains are coming out, which decrease the decreasing the pore water pressure. The effective increases by decreasing the effective stresses. The soil gets consolidated, pre-consolidated. It gets pre-consolidated with the help of producing negative pressure. So due to this technique, our ground get improved. So let me write the equation which is here. So as we have total stress is equal to sigma effective plus pore water pressure. So by increase, as we know that total stress must be remain constant. So by decreasing the pore water pressure, in order to keep the total stress constant, sigma effective must have to be increases. So in this way, sigma effective increases and pore water pressure decreases. So due to which our soil get compressed and consolidated, due to which our soil get quite improved. The second one is ground freezing. Ground freezing is the use of refrigeration to convert in situ pore water to ice. What is happening in the ground freezing? That some refrigerant is provided into the injected inside the ground, which freeze the soil. And this is not permanent. This is for temporary. For example, if somewhere dewatering is not working, so then we go for ground freezing. And then after that, we have impact compaction. Rapid impact compaction densifies shallow and granular soil using hydraulic hammer repeatedly strikes on the ground surface. So here is the animation. This is with the help of heavy hammer. So due to that impact loading, the soil quality get improved, and now we can construct tall structures on this surface. So this is one of the improvement of ground. So the next one is soil cement stabilization. What is happening in this? A cement or a ground is mixed with the soil, which stabilize or the ground, the soil present in that region. This will be explaining in the animations in the next slides. So mechanical soil mixing. What is happening in mechanical soil? That some heavy machinery makes the soil, and this is two type of, one for shallow and second one is for deep. So this is the video for deep soil mixing. the grout is produced on site and pumped to a soil mixing. And now here, as you can see, the grout is mixing with the soil, and that is quite deep inside the ground. So this is the mechanical soil mixing with the new grout, and this grout is prepared in situ. So this is the mixing of the, if we are going for deep foundation and deep soil improvement, so we will go for mechanical soil mixing like in that way. So we have for shallow soil mixing, this is same as that, but this is for shallow foundation. If the soil present, if the soil near the ground surface are not able to are not able to require to sustain the to sustain and the required loading. So what we will go for shallow soil mixing. So these are the excavators, and for shallow soil mixing we are using this technique. So the next one is the next one is vibration. Vibration compaction is one of the most economical mean of compaction and for compacting embankment of sand or natural layer of loose sandy cells. So in the vibration technique, normally we use the heavy machinery like roller, compact roller, pneumatic type rollers, and the vibration, they vibrate the soil. Due to that, the effective pore water pressure decreases. Due to that, the soil get consolidated. So now the next one is pre-compression. In the pre-compression, this is same as I have discussed one previously. The pre-compression, the site is preloaded by mean of surcharge. In the pre-compression, the site is loaded by surcharge by a weight, and the water comes out through the provided drains. Like here, it is shown in the figure. While in the previous one, the water comes out with the help of vacuum pump. And in this slide, the water coming out because of the surcharge load, and due when water comes out, so the same phenomena occur. The effective stresses increases, and the site get quite improved. So in the explosion, what is happening in the explosion? When the soil get exploded, the final density, the soil get exploded. Due to explosion, the soil get densified because the water will come out from the soil, and the soil will get the soil will get densified. So here it is explained the final density may not be achieved immediately as the dissipation of excess pore water pressure. As in geotech, when we already presented this, I have already presented this topic. So at that time, you are not understanding this term, that dissipation of excess pore water pressure. But now in this stage, we can understand the dissipation of excess pore water pressure. That with the excess pore water dissipation, what will happening? So this is the one of the benefit about today's presentation. I feeling myself, and this is the explosion. So what is happening here? This is exploded, and the soil will get settled down. The water is coming out. So heavy damping or dynamic compaction. In the heavy damping or dynamic compaction, a large mass is dropped onto the ground surface, causing compaction and long-term consolidation. An existing surface or near surface soil is poor. We use this technique in both for cohesive and non-cohesive soil. And this may be clear from this video. This is provided in multi phases. So the next one is vibratory compaction. Densification is achieved by vibrating a probe or pile, sometimes aided by water jet or pressurized air and the addition of granular material. What is happening that a vibrating probe is vibrating and some grout material or water it's injected and it is bored deep into the soil which densify the soil. Here in the animation you can see that some grout is pouring lower down. And this is done with the help of vibration. Compaction or jet grouting. Compaction grouting, also known as low mobility grouting, is a grouting technique that displaces and densifies loose granular soil, reinforces soil and stabilizes subsurface voids or sinkholes by the steady injection of low slump, low mobility aggregate grout. And jet grouting is a technique of mixing in situ soil with the energy of high pressure jet of slurry. A small diameter rod is drilled and down for the improvement. This is like the previous one, but in this case, a grout is injected inside the ground. Like here, it is in the shape of balls, which quite improve the quality of soil. This is compaction grout, and this technique can be done in the soil above which already a structure could be built. So this is the advantage of this Vibro compaction and Vibro replacement. Vibrators are generally attached to the top steel which are lowered into the ground. The dominant direction of vibration is vertical. This is also done with the help of vibration, and stone columns are made inside the ground. So this is another animation. What is happening here? So in this method, the stone columns are made with the help of vibration inside the ground, which improve the quality of soil. And this is quite same with the help with the previous one, but in this case, we made a concrete column inside the ground. In this technique, a deep soil layer is reinforced by concrete grouting. This technique is used for fine grained soil. The concrete pile acts as a load bearing member. So here you can see this is the last one. The help of this vibration, the columns are made. And this vibration plays an important role because the soil present in the vicinity of this column get also densified with this vibration. So this all from our side. If anyone have got any question, they can ask.
Thank you so much, Ashad. Excellent animations and excellent presentations. Okay, the presentation was very, very good. The reason behind that was that you made a link between Geotech 1, Geotech 2, and the foundation engineering. And that was the reason. If you remember, I used the words, particularly the shallow and the deep. Now you can see that why I use the word shallow and deep in Geotech 1. The reason behind those two words were that the first, if you want to use shallow foundations and if the bearing capacity of that soil is not appropriate, then you can use shallow mixing technique to enhance or increase the bearing capacity of that soil. Now, for example, if you are going for the deep foundations, So we can use the deep foundations or deep compaction techniques to improve the bearing capacity of those soils. So it's good. I like the way you made a link between the different courses and different subjects that helped you in understanding the concepts in the field of geotechnical engineering. Thank you so much.
Thank you, sir. Thank you, sir.
Okay, who is next, please? Okay, we are having 13 slides there, so maximum 10 minutes, please. Thank you.
Assalamu alaikum. My name is Owais Zafar. My group members are Hezbollah, Enamullah, Ijaz Azim, and Muhammad Usman. Today, my presentation topic is ground improvement techniques. Next. At this stage, the question arises that why we improve soil. Answer of this question is that to prevent excessive settlement of the soil, to improve the shear strength of the soil, increase the density of the soil to prevent liquefaction, to improve soil permeability, in order to increase the drainage capacity. Next. These are the different techniques which are used to improve ground. At this stage, a question also arises that why we use different techniques instead of one technique. The answer of this question is that the techniques depends upon three conditions. Number one, cost. Number two, loading. Number three, soil types, soil condition. Number one, Vibro Compaction. Vibro Compaction is the rearrangement of soil particle into denser configuration by the use of powerful depth vibration. Vibro Compaction is a ground improvement process for densifying low sand to create stable foundation soil. The right side picture show the Vibro Compaction. These are the video the left side. Click on that. Please click on the video. These are the Vibro broker. These are inserted inside the soil mass with the help of water. These are inserted inside the soil and also vibrate. These are crane. Next. Vacuum consolidation. Vacuum consolidation method is a technique of applying vacuum suction to an isolated soil mass to reduce the atmospheric pressure in it, thus reducing the pore water pressure in the soil. The effective stress increase without changing the total stress. We used a pump in it and install pipe inside the soil mass and suck the pore water pressure inside the water which is present inside the water. Thus the effective stress inside the water is increases, thus the soil is compacted. Show the video. These are the pump which suck the pore water pressure. These are the pipe arrangement. These are the pipe arrangement.
You can increase the size of the video as well. Yeah, just
Hezbollah increase the size of the video.
yeah, a little bit more. Yeah, from the top.
From the top also increase.
Yeah, looks good now.
These are the pipe. These are installed. These are the pump section. These are the pour water pressure.
And you know that pore water pressure significantly reduces the bearing capacity of the soil as well. So that's why they are removing using the vacuum consolidation. So they are trying
Yes,
to
sir.
remove that pore water pressure.
Yes,
Good,
sir.
excellent.
Next. Preloading of soil. Preloading is an economical and effective soil improvement method that can reduce settlement and increase the bearing capacity of subsoil. Preloading forces water out of the soil matrix, facilitating soil consolidation. In this method, we apply load in the soil due to which the soil is compacted, and after that we remove this load and install and in construct building or next. Ground freezing. Ground freezing is a construction technique used in circumstances where soil needs to be stabilized so it will not collapse next to excavation or to prevent contamination spilled into soil from being leached away. These are the picture of the freezing. Start the video, please, Hezbollah. In this method, pipe are inserted inside the soil mass. These are the practical video of the field. Pipe is inserted inside the soil mass. Other pipe is inserted. In this method, the pipe is inserted and also uh, refrigerator refrigeration. Sir, can you hear me?
Yes, voice is clear. Your voice is clear.
Okay, sir. Sir, these are the methods in which we compact the soil to increase the shear strength of the soil. Next. Soil kneeling. Soil kneeling is a construction remedial measure to treat unstable natural soil slope or as a construction techniques that allows the safe overstepping of new or existing soil slope. The basic design consists of transforming the resisting tensile forces generated in the inclusion into the ground through the friction mobilized at the interfaces. Start the video, please. You can see that the Nile is preparing to insert the soil mass. These are inserted into the soil mass. Concrete is injected into it. These are the concrete which is inserted into the knee. These are the gauge.
And just to let you know that I heard from a few friends that beneath the foundation of the Diamond Mall, just beside the Gulhaji Plaza, they used the same soil nailing technique there.
Okay, sir. Next, Vibrostone columns. Vibrostone columns are also known as vibro replacement. It is a construction of dense aggregate column with a downhole vibrator suspended from a crane or specially built rig. The stone column and intervening soil from farm and integrated foundation support system having low compressibility and improved load bearing capacity. Next. Now I am inviting Ijaz Azim to present further. Ijaz Azim, please. Ijaz, can you hear me?
Ijaz.
Fine. Always, we are having a micropiles. Okay, so micropiles are installed there, and
Yes.
they are used to densify the soil, and then you place the foundation on top of that compacted or densified soil there. What's the next slide, please?
Hello, sir.
Yeah, go to the next. No problem. It just no problem. That's fine. Grouting, grout is used to strengthen the soil as well, just to increase the bearing capacity and shear strength of the soil. Go to the next slide, please. Jet grouting, yes, it's done. Yeah, okay, we heard about that as well. That is also a good technique to enhance the bearing capacity and shear strength of the soil. Go to the next one.
Sir.
Next one, please. Go to the next one. Is there any animation there in dynamic compaction?
No, sir.
Okay, no animation there. Excellent presentation. I don't want any interruption there. So I want to, and I can't hold my comments on the Awais Zafar presentation. In the 3-minute thesis competition, they say that if you need a single slide, and if that slide is enhancing your presentation, the message which you want to communicate, so just provide that one static presentation there, and then you talk. Look, the thing is, if you see the accent, the Awais Zafar accent is subcontinent accent. Chinese, they have their own accent. Singaporean, they have their own accent. Indians, I would say, Japanese, all the countries, they have their own accent when they talk in English. So when Awais Zafar was talking, honestly, the animations, can you hear me?
Yes, sir.
The animations, the way he used those animations, that was adding to his the message which he was trying to convey to the audience. So excellently done, Awais. Thank you so much for excellent presentation.
Sir, basically I cannot see the slides because I am from outside the home.
Believe me, the best way which you communicated and the explanation about the animations and those videos, I don't know, you are saying that you are not seeing the videos, but
Yes,
the way
sir.
you were explaining all those steps, those were happening in the video. So I was enjoying every bit of that explanation. So when you were saying that, Ijaz, so you don't need any other group member, so I don't want any other member to delay your presentation. So those animations, those videos, please watch that video, and this will help you a lot. Even if you are unable to speak in particular accent, it doesn't mean that your presentation won't be amazing. And it was sounding amazing to me and excellent. Thank you very much, Ares, for your excellent presentation.
Okay, sir.
Who is next, please?
सर मैं present करूं?
Yes, Asad Mir. Yeah, you requested for that. Yeah.
Yes. सर मेरी स्क्रीन नजर आ रही है?
Yes, screen is visible.
Yes, sir. Bismillahirrahmanirrahim.
10 minutes.
Sir.
I have a request, Asad, 10 minutes
Yes,
maximum, please.
Yes, sir. Sir, these are my group mates, Asad Mir Muhammad, Aswan Jar, Amjad, and Sayyid Muhammad Anis. The topic of presentation is various ground techniques, improvement techniques used in geotechnical engineering. So, ground improvement techniques on the basis of mechanism by which they improve the engineering properties of soils. We have densification technique, reinforced technique, and stabilization technique. These are the main techniques which are used by the engineer to improve the ground. So the reason and behind that we improve the ground, is that we need the shear strength of the soil, and the other is to improve the permeability, and also to improve the density of soil, so that we use these techniques to improve these things. Is it, sir?
Yes, please continue.
Yes, sir. Yes, sir. Now, so because of the shortage of time, I only explain the main techniques which are used in the ground improvement. So we first of all we have compression of soil. It requires only conventional equipment, earth moving equipment, which is readily available. Any grading contractor can perform it. The method has a long track record of success. And the last is the surcharge must remain in place for months or years, thus delaying in construction. So the next is this densification technique. The strength and stiffness of the soil is higher when the particles are packed in a dense configuration, and then they are packed loosely. As a result, this densification is one of the most effective and commonly used means of improving soil characteristics. This can be approached in following ways. So first of all, we have dynamic compaction. Dynamic compaction is normally used under the following circumstances: to increase in situ density and this way improve the bearing capacity and consolidation characteristics of soil, to allow conventional foundation and surface bed construction to be carried out. The technique typically improves the in situ soil, such as allowable bearing pressure of up to 250 kilopascal can be used with foundation settlement of the order of 2 to 20 millimeter. So what soil are suitable? Most soil types can be improved, including silts and some clays. The most commonly treated soils are old fill and granular virgin soil. Soil below the water table are routinely treated. However, careful control has to be used to allow self-destruction of this. So now the next is blasting. Blasting is most effective in loose sand that contain less than 20% of silt and less than 5% of clay, and how blasting is quite economical. It is limited by severe consideration as it produces strong vibration that may damage nearby structure or produce significant ground movement. So now the next is reinforced technique. In some cases, it is possible to improve the strength and stiffness of a existing soil bed by installing discrete inclusion in the soil. This inclusion may consist of structural materials such as steel, concrete, or timber, or geometrical such as these densified gravels. And now the compaction piles. Compaction pile improve the seismic performance of a soil by three different mechanisms. First, the friction strength of a pile themselves provide resistance to soil movement. Second, the perception and displacement produced by their installation cause densification. Finally, the installation process increases the lateral pressure in the soil surrounding the pile. Now we have jet grouting. And jet grouting, in this type of grouting, the soil is mixed with the cement ground injected horizontally under high pressure in a previously drilled borehole. And the next is jet grouting. Grouting uses a special pipe equipped with horizontal jet that inject grout into the soil at high pressure. The pipe are first inserted to the desired depth, then they are raised and rotate while the injection forming the column of treated soil. Now, if someone have any question, then he may ask.
Thank you so much, Asad. Thank you for the presentation. It was a bit quicker than what I was expecting, but good job. No problem. Okay, we were waiting for the animations, and there. No problem. It's okay. I understand because you are at the end of the class, so many already presented it, so they have the idea that what they are going to see there. So thank you so much.
Sir, the reason behind this is that I am going to towards my home, and I am now in the car, so that I'm not explaining my topic quite better. Okay, sir.
No problem. Thank you so much. Thank you for your participation. Participation itself is the biggest contribution, from your side.
Thank you, sir.
Thank you so much.
Later on, I will try my best. Okay, sir. Thank you very much.
Thank you.
Thank you.